All right. I'm not sure if the others are going to be joining us, but I wanted to kindly ask if perhaps somebody can just confirm whether or not you can see my screen, and also if you can hear me just fine. Hello, can you hear me?
Yes, we can do.
Okay, thank you very much for confirming. Really appreciate that. So before we start, just I think a reminder, two things. A reminder that I believe we have a class on Saturday at 16 hours. I have actually already scheduled this class. Apologies that I couldn't make it yesterday. I was attending a meeting that took significantly longer than, well, the meeting was scheduled to start at 14:30 anyway. So the initial plan was, and I know it was short notice, the initial plan was to move the class to, is it 13 hours, but I think it was short notice for a number of people, and so we eventually just ended up canceling the class. We have since moved the class to Saturday. I'm sure if you check your calendars, you should see this thing scheduled here, but it doesn't really matter because we use the same link actually to have class. So Saturday 16 hours, I believe it is, we have class. And then the other thing I wanted to mention is, I'm not sure how many of you are keeping tabs or keeping track of the resources on the resources on the Google Classroom site. Maybe I can access this using my account because it's added as a student. I added so there's a book that is it's actually referenced in a number of modules in the module document. And so what I did was I decided I would share the relevant chapters associated with what we are doing right now. So I'm specifically making reference to the things that you will find under. So there's a course material that's tagged as supplementary material here. I actually also added a comment which I suppose most of you would have seen or something. So you notice that there's an excerpt or an extract of a chapter on software, a chapter on information systems overview, and also a chapter on hardware. The thinking is that I think it's an easy to follow book, really, to be honest. So the thinking is you should be able to hopefully complement what we're discussing in this module with what you will find in that book. Anyways, so that's that. And I'm hoping that maybe by Saturday, when we have the makeup class, we'll probably wrap up this module. If not, then we're probably going to wrap up on Wednesday next week or something. I don't know. But anyway, so we are going to continue our discussion of module number 2, which is really tagged as social protection management information, well, fundamentals of management information systems. And if you remember, we're coming from a kind of background where we've discussed data and information. We broadly looked at information systems, and then we are currently looking at the information technological infrastructure, right? So these different important components that will comprise what we're calling the IT infrastructure. We started our discussion with software, then we started with hardware, then we looked at software, and during our discussion of computer software, we actually realized that there's a broad spectrum of computer software. All right, we looked at the various categories of computer software, and in all of those different instances, when we were discussing different types of computer software, be it our discussion of application software, which is a category or a subcategory of computer software, or system software, which is yet another subcategories of computer software, we kept on making reference to aspects of these different subcategories of software related to our current focus of discussion, which is management information systems. All right. In some instances, we did highlight that we would probably touch on these things later on down the line. Like, for instance, when we're looking at malicious software, we mentioned that there's a dedicated module that looks at data protection, ideally, privacy and data protection. Anyways, I'm not sure if people have any thoughts or questions about computer software before we transition to the communications infrastructure, which is the third leg or the third element, the third out of the four elements associated with the information technology layer of your typical information systems. I'm not sure if people had a chance to look at or to sort of like take in some of the things we've discussed. If there are no questions, then we can proceed and look at the so-called communications infrastructure. So fundamentally, what the communication infrastructure does really is it plays a crucial role of facilitating the transmission of data across. So this would be across the management information systems infrastructure. And this makes sense, right? It makes sense if you think about this discussion relative to our discussion of the high-level overview of what happens when a client machine is accessing a management information system, which would typically be accessed on a server computer system, right? So this client machine is typically associated with microcomputers, so our laptops, our smartphones, and desktop computers, tablets, and all those things. But because you're accessing this server computer system, the server computer system could be physically located elsewhere. This is, in fact, the case when we're dealing with cloud computing. Right? So we see that the server computer system could be located in a completely different country, right? A different part of the world. Even if the server was maybe physically located in Zambia, for instance, in all likelihood, maybe it would be located in a completely different building. There has got to be a mechanism, right, which has to be used in order for these requests and the responses to be transmitted to and from the client or to and from the server computer system, right? And it turns out that the infrastructure that is used to facilitate that transmission of important information, we call this data here because it's a raw facts, is what we are calling a computer network. All right. I'm trying to see here. Yeah, it's what we're calling a computer network. So in essence, the communication that takes place really within a computer network is typically between what we are calling network nodes or network hosts, right? In some instances, depending on what sort of data you're sending, you could be sending this data between two client machines. Like for instance, if you decide to send an email to a colleague, right? What you're doing is you're sending that email from your client machine to a client machine, which is obviously associated with a microcomputer, to a colleague who is in all likelihood using yet another microcomputer system. So we see that the communication that's happening there is between two different types of microcomputers. Okay, and you're exchanging data here. The network node could be what we'll be interested in when we're dealing with the management information system, right? In which case the communication would be between the client that an end user would be using, it should be a microcomputer, and a server computer system, bearing in mind that the MIS platform that the client would be accessing is hosted on a server computer system, right? But we see that this idea or notion of network hosts or network nodes actually encompasses a broad spectrum of hardware components. Some of these hardware components could be things that are not really your classic computer system, like for instance, a network printer or a scanner, all right? Or it could be an embedded computer system such as a router, for instance. So think of the routers that are used in these large organizations that would typically have management information systems installed, are different from the routers, the personal routers we buy from these mobile network operators. If you've bought a router before, you know that we are referring to those small devices that MTN Zambia router, those small devices that these mobile network operators will be selling, right? So things similar to these things here. I don't know how many of you use these routers here, but it turns out that this is actually a type of computer system. It's an embedded computer system. All right. It's just that it's not your classic computer system, because typically it will not have a corresponding screen or something that you'd use to interact with this computer system. For the most part, you interact with this by using some button to switch on and off the gadget or something, or to reset the password, and all those things, right? Shut it down and all those things. But anyway, so the network host really will involve, or will encompass, all these different types of hardware devices, right? Anyways, so your computer network is actually essential, right, in facilitating the transmission of whatever data you'd be sending between these different network nodes. Again, the data that you're sending between these different network nodes is dependent on the type of node that a client will be interacting with. Yeah. So in essence, this thing we are calling a computer network is nothing more than a collection of these different network nodes, right? So if you look at an SME, for instance, in all likelihood, an SME, a typical SME will comprise, maybe, let's say, hypothetically speaking, about 5 individuals, right? That perform different roles. Each of those 5 individuals will generally have a client computer system, a microcomputer that they'll be using to perform their day-to-day tasks, right? But because those individuals would need to share important information like files, they would need to communicate with each other, we see that collectively their computers that they're using will be interconnected via what we're calling a computer network. So simply put, a computer network is nothing more than a collection of interconnected network nodes. Again, these network nodes would be, computers, network printers. These days, IP phones have become quite popular as well. In some instances, depending on the size of the organization, you could also have different types of servers. If you remember our discussion of servers, this is a broad category, right? This could be web servers. This could be, simple mail transfer protocol servers. This could be FTP servers. This could be storage servers, right? But anyways, it's neither here nor there. So it turns out that this interconnection of these different network elements, or network nodes we are calling them, will make it possible for these clients to share important organizational resources. All right. So your typical computer network will fundamentally be utilized by users, right, within that organization to share important resources. These resources could be hardware. This makes sense because some of this hardware that forms these computer networks should be things like your IP phones or your network printers. If you look at a network printer, the idea behind the network printer is, if you have a large organization, like, let's say, ZRA, for lack of a better example here. ZRA is an organization will comprise of departments and perhaps even units or something. The idea behind the network printer is, instead of purchasing a printer for each individual working for that organization, like individuals that need to print stuff, what you can do is you can invest money in a printer that will be used for each department in that particular organization. And because it's a network printer, any individual within the organization's department who wishes to print something will make use of that network printer. So in essence, people in a particular department would be sharing that piece of hardware, which is a network printer. The same can be said for these so-called internet protocol phones or IP phones, right? So maybe if you're sharing an office with other people, you only have one IP phone that you can use to communicate with other individuals within the organization or something. And then the issue of software here makes sense, because a classic example of a piece of software that you would be sharing via the network is this management information system. Seeing as your typical management information system is web enabled or is web based, right? So you typically have this one piece of software installed on a server computer system, and everybody in the organization who wishes to interact with, that management information system would essentially use the same piece of software. But also, we see that another example resource that is shared within this interconnection of network nodes is the data itself. Again, if we look at the example of the management information system, we see that the summarized raw data that is collected by this social protection management information system, for instance, or the data that is used to generate reports or summaries of the information or the data collected is accessed by a broad spectrum of users. You're sharing the data, right? There is no need for each individual to have a separate, is it data source or something? You just use this shared resource associated with the management information system. But also, we see that this interconnection of these network nodes enables effective electronic communication. Makes sense here if you think about this effective communication from a perspective of the primary or the common formal way of communicating in the 21st century, right? Email. You are able to send an email to a colleague or a boss or something because your computer, the client machine that you're using is typically on this, communications infrastructure you're calling a computer network. Anyway, again, if we can, kind of latch on to what we introduced as like a formal definition of an information system, we actually defined it as being an organized combination of people, hardware, software, communications network, or infrastructure, and data resources that collects, transforms, and disseminates information in an organization. And we see that if you look at this definition, we see that the communications infrastructure plays the crucial role of ensuring that this process of collecting data and transforming the data and disseminating the information is effective, right? So if we were to use the example of this, and I hope we have it somewhere here, there's that very nice diagram that showcases the various elements associated with is it this piece or something? I don't know if people remember this, but I'm going to go back here and hope we'll be able to find it. No, not here. It appears there. There we go here. We see that the collection of the data, right, is typically done by these microcomputers. So your smartphones and your tablets, and perhaps in some instances your laptops, via some application software typical associated with COBOL toolbox is called here. But we see that the process of submitting this summarized data that is collected by laptops, tablets, and smartphones is facilitated by this communications infrastructure. Because these client machines here are separate from the server that is used to store this information or the data being collected. So you need a communications infrastructure, right? Hence, the statement where we are saying that the communications infrastructure is there to facilitate the effective collection, transformation, and dissemination of data, right? Associated with in this case, the social protection management information system. Here's to hoping all of this is making sense, ladies and gentlemen. But anyway, but I guess for us to gain a better appreciation of what we're talking about here, it becomes important for us to just briefly, appreciate how this information is transmitted. Now, I included these details in the slides because my thinking was that you were going to be able to better understand. Sorry about this. You're going to Apologies. I just received a call and I just want to tell this person that I'm in a class. Thank you very much. Right, sorry about that. So for us to better understand this, right, it becomes important to better understand and appreciate communications, computer networks, the communications infrastructure. It becomes important for us to understand exactly how this data is transmitted. Not exactly very relevant to MSP 5012, but I just felt that people will be able to better understand and appreciate this discussion if we briefly spoke about this. Suffice to say, this would be at a very high level. So if you remember, at some point we had a discussion about how a client machine gets to interact with the server, right? This notion of your request response cycle. So if you are accessing a management information system, we discovered that typically this management information system would be hosted on a server computer system, and the client will typically initiate contact with the server by specifying what resource is required, right? So maybe it could be that you're generating a report. So you send a request, which by its nature will have important details that will make it possible for the server to send back information about the report you're interested in. Okay, so the client sends a request, and then the server will send back a response. And because this happens at a very fast rate, I mean, we take it for granted that there's multiple requests that are typically sent to a server. But anyway, it turns out, right, that the process of sending this request and receiving the response associated with the request really is a lot more complicated than we made it seem when we had this discussion, right? So there's this notion of packet switching, which is associated with how data is transmitted over the network, right? A typical request or a response that comes back from a server is typically to be relatively large in size, right? Depending on the sort of information that you're getting back, and maybe we can use the example of the COMIS here, so that people hopefully understand, right? Right? So that people understand here. So what we're saying is when let's say I want to, so I'm about to log in here. Let's say I want to access a report associated with payment, like payment reports or something. What I will do is I will initiate communication with the server, or at least my client initiates communication with the server. All of this starts with me, specifying the address in the browser or something. Sorry, this is taking a while here. I hope it loads eventually. At some point, the server will send back details associated with the report that I'm interested in. Now, if we are to measure the size of the data associated with that report, those graphics that you see, the textual information to say, let's say, X Zambian kwacha was, let's say, maybe disseminated in the month of July, for instance. The response that is sent back to the client is extremely large, such that it becomes impractical for that message to be sent in one piece, right? And so typically what will happen is the data is broken up into smaller units called packets, okay? And if you read up on the anatomy of the packet, you begin to realize that if you're splitting up a message into smaller bits and pieces, it makes sense that there's a way of uniquely identifying these small pieces, right? And identifying these small pieces could entail you associating information like where this packet is going to, like which computer on the network is expecting this information, which other packets is this information associated with, right? So that when all these different packets associated with the data I'm interested in reach the client machine, they'll be assembled into one piece of data that I can then access using my client machine, right? I don't know, this thing is taking long here. I don't know if this makes sense really. And so it turns out that each network node, so like your computer, for instance, or the server computer system itself, will contain the necessary software that will be required to interpret those different data packets, right? And you can actually use certain types of utility software tools to better understand what goes on, right? Observe. One of the things I can do here is I can do a simple ping here, or not really a ping, but I can do a trace route, try and perhaps to try and showcase this sort of path that a packet would take, so that you appreciate the importance of this. I suppose trace route. If, let's say, I was interested in downloading, for lack of a better example, in downloading data that is hosted, let's say UNZA, for instance, right? When I'm accessing information from the UNZA website, if I go to the homepage, what we're saying is that the information associated with the data that is located on the UNZA homepage, all of these graphics we are seeing, piece of text, and all these different articles and job advertisements and all these things will be sent back to you in bits and pieces. And what makes it even more complex is that these bits and pieces will take different paths, right? So if I was to do a trace path from my client machine, my laptop, to the server that is hosting the UNZA website, we begin to see the sort of path that, in this case, this would be the path that the packets I'm sending is taking. And by the way, this is a bit simplistic here because I'm located on the UNZA network, right? So it's like I have direct access to the server itself. Observe what happens when I try to do the same thing. So you notice here I have 4 hops here, right? So I'm passing through some gateway here. There's this other computer I'm getting through before I eventually get back the data, or before the data gets onto the other side of the network. In this case would be the server here. But notice what happens if I do a trace route for maybe an application that I know is located in a different part of the world, right? It's Facebook. What you begin to notice is that the path is much longer, right? Because the host that my client machine, or the server that my current machine is interacting with in this case, is obviously located in a completely different geographic area than I am right now, right? And so what we're saying is all these different individual packets that will be associated with a typical resource or data you're interested in, it could be a web page, for instance, would take different paths, right? So this could be one of the paths taken by, let's say, information coming in from Facebook to my client machine, for instance. But anyways, there's the necessary software required for these for your computer or the server computer system to be able to interpret this data, is what we're saying. Just a visual representation here showcasing exactly how this happens, right? So my client machine in this case could be maybe sending information to some server, could be Facebook, where I'm initiating contact with Facebook to say, I want to access my profile. That information, that request will be broken up into packets. And what we see is that the packets will take different paths before they get to the other side of whatever network host you are interacting with. The opposite is true, right? Because when you send a request, you're expecting a response back. The response is again broken up into smaller pieces, smaller units we are calling packets, and those packets will take different routes before they get back to the client. Anyways, and again, sorry that we're discussing, this whole notion of the computer network by looking at the lower levels of abstraction in terms of how like a typical packet is transmitted. But if you look up information about certain layered network architectures like the OSI model, as it's commonly referred to, you begin to better understand exactly how these packets are transmitted. So simply put, this layered network architecture called the OSI model, really, the way it works is you have these logical layers that play different roles insofar as transmission of data is concerned. All right. In total, there's about there's about 7 different layers. And because these layers are associated with the machine that is sending the request, in the case of your interaction between your client machine and your management information system, your OSI model is associated with both the client machine and the server computer system. On the client machine, because the client machine is the one initiating contact with the server, what would happen when you're sending a request to a server is that request will originate from the application layer down to the physical layer, after which so-called bits associated with these different packets would be transmitted over the communications infrastructure, the computer network. And then on the other side, what you have is a reverse of what you're seeing, right? So on the other side, the bits will hit the server computer system at the physical layer and then move up all the way up the application layer, so that the server is able to process the request, and then a response will be sent back. The response does the same thing that your client does, right? The response originates from the application layer, it moves down to the presentation layer, session layer, all the way up to the physical layer, and then the bits will be transmitted over the communications infrastructure, the computer network, onto the client. And then, of course, on the client side, those bits will eventually hit the physical layer and then move all the way up to the application layer, right? And really, in summary, the specific roles that each of these different logical layers will perform. So the physical layer is there to help the transmission of the raw bits, right, through the physical communication medium, the computer network. Remember, the computer network could be like physical wires. If you've connected your client machine, let's say your laptop, to an Ethernet port, right, using an Ethernet cable. So you're transmitting those bits via that communications infrastructure. If you're using Wi-Fi, the same thing applies, right? You're transmitting bits essentially. The data link layer is there essentially to facilitate the reliable transfer of, the data frames associated with the packets, right, through so-called point-to-point links. And then your network layer is there to facilitate the routing of the data packets through the links. The transport layer makes it possible for data packets to be reliably transferred, right? There's typically mechanisms in place to ensure that there's seamless error handling or error recovery, but also what it does, it facilitates the flow control of the data being transmitted. The session layer is there to manage the transmission sessions, bearing in mind that the packets that would be originating from a client machine, or the packets that would be destined from a client machine or a server computer system, would be a lot, right? They'll be associated with different types of data. At any given point in time, if you think about how your laptop works, at any given point in time, you could be doing a range of things, right? You could have your email server open, your browser can have your email client to be open like it is now. You could be accessing other web applications. I'm accessing the UNZA website. I'm accessing this demo instance of CoreMIS. So at any given point in time, you could be sending data associated or destined for different servers. The question is, how is it possible that you're able to identify packets that are associated with these different types of applications or different type of data that is sent and received? Well, the session layer is there for that particular purpose, right? So it manages the transmission sessions essentially. And then the presentation layer will provide data independence. And then finally, the application layer is there to act as an interface point for end user applications. So in essence, most of these software applications that we use, right, to access, let's say, web services, for instance, we access them at the application layer. I am using the web browser to access my email, to access CoreMIS, to access the UNZA website at the application layer, which is here. Yeah. I'll pause here just to find out if people have any questions and again, my thinking was that having having this discussion will probably be able to help people better understand how all of this works, right? Also, maybe for you to be able to better understand this, you want to think about this discussion relative to an application, maybe one of the applications you use often, right? It's like when you're sending, what we're saying here is when you're sending a WhatsApp message to somebody, right? Let's say you are sending a hi message to somebody. What we're saying, right? If you look at the Oz model here, is that this hi message will be sent via WhatsApp at the application layer. But as part of the transmission process, it passes through these logical layers here, these additional 6 layers. So from the application layer, the hi message will get to the presentation layer, the session layer, the transport layer, the network layer, the data link layer, up to the point in time when this hi message is going to be broken up into packets, data packets. Those data packets, a nice thing about these data packets is they're converted into so-called ones and zeros, right? Actual bits, raw bits, and then transmitted over communications infrastructure, which is a computer network. And then on the other side, because you're sending this hi message to somebody else, who is likely using a phone as well, on the other side, because this hi message is a series of ones and zeros, what we're saying is on the other side, these ones and zeros will first of all hit the physical layer. So from the physical layer, the ones and zeros will move all the way up to the application layer until they get to a point when these ones and zeros will be then converted again into the hi message, is what we are saying here. All right, so before we start our in-depth discussion of so-called computer networks, I thought it would be nice for us to gain an appreciation of like the broad spectrum of computer networks, right? Turns out that there are a number of them. And what better way than to use things that we have used or things that we can easily relate to. It turns out that the way that we normally access most of these services that are located on servers hosted like outside the boundaries of our respective countries is made possible by underwater sea cables. So if let's say you're interested in accessing Facebook, because we are located somewhere here in Zambia, if you look, I don't know if this is going to be helpful here, probably not here. But the data, the request that you're sending to Facebook to say, I want to access my profile or something, needs to be transmitted to a server that is hosting the Facebook application. The normal way, right, with which we actually send that request is we gain access to these underwater sea cables. Because we're landlocked, there's fiber that has been laid down here that will typically originate from places like South Africa, for instance. I'm not sure if we have direct fiber connections from places like Mozambique, for instance, but I do know that most of these mobile network operators like MTN and Liquid and perhaps Airtel, for instance, will tap into this infrastructure, right? Essentially, what we're saying is that the way that it's possible for us to communicate with the outside world because we gain access to this larger network, right? As luck would have it, this is a classic example of what we'll be calling a wide area network, right? So a classic example there. Closer to home, we see that there are various initiatives that have been instituted. The most popular one is so-called Fibercom. I don't know how many of you have heard of Fibercom, but the idea behind Fibercom, which is a spin-off of Zesco really, is that they're laying down this high-speed infrastructure, right, made of fiber throughout the Republic of Zambia. The idea behind this is you want to be able to efficiently transmit data, right, within Zambia. I was actually surprised when I was traveling to the Eastern Province a while back. I realized that I think there's fiber that has been the way that they're laying fiber here is they're not really laying it underground, but I think they are taking advantage of is it Zesco pylons or something, right? Which is interesting. So this image is just showcasing, I don't know how recent this is, it's just showcasing the interconnection, the fiber connection within Zambia. I think this was as of 2017. I'm sure this thing has changed here. The bottom line is there's this interconnection of different nodes, right, within Zambia. This could be like government infrastructure or infrastructure associated with, significantly large corporate organizations, for instance, that will tap into this existing computer network, right? A wide area network, restricted to the boundaries of the Republic of Zambia. In all of these different examples, what you will notice is that the medium that is used to facilitate this interconnection may be different, right? In this case, there are actual physical wires that are used, right, to transmit data. So is this case. But the medium, the communication medium that is used when I'm using my phone right now also includes Wi-Fi. Yeah, so you're taking advantage of really a mode of communication that doesn't necessarily require physical connections between the network nodes. That doesn't take away the fact that the computer or the phone that you'll be using at that point in time is a part of the network that you're connected to. So in my case, because I'm using the MTN network to connect to the internet, we see that I'm taking advantage of the MTN network, which in turn will tap into this existing infrastructure. Yeah. Anyways, in the education sector, there's interesting initiatives that have been instituted. I don't know how many of you have heard of so-called education research networks. The idea behind education research networks is you're setting up. It's an initiative that is aimed at setting up these high-capacity networks that will facilitate the transmission of data associated with research. So think of the type of work that entities like UNZA or CBU will do. What's interesting about these education research networks is that there are regional initiatives that have been instituted, but also country-based initiatives. So in the case of Zambia, we see that this education research network is what has manifested into what's called ZAMREN. I don't know how many of you have heard of ZAMREN, but the idea behind ZAMREN is they've actually set up this countrywide network, a wide area network that makes it possible for people that are accessing information via the UNZA network to be able to easily communicate and share resources with people located or associated with the Copperbelt University or something, or UNILAS or ZICAS University. This, in fact, is the reason why those of you that have activated your account will be able to use EduRoam not only when you are on UNZA, on the UNZA network, but also if you find yourself at ZICAS. The same EduRoam at ZICAS can be, you can access the same EduRoam at ZICAS using your UNZA credentials. It's like you're roaming, right? So there's a mechanism in place to easily identify who you are. All you need is to have a valid, I guess, identity that can be used to authenticate yourself to access the network. Again, a classic example of the wide area network. But of course, other examples that I think we will discuss as we further, continue this discussion on computer networks, are these networks that are associated with your respective organizations, right? When you're at work, we see that it's a lot easier for you to communicate with other people, even when you are not really connected to the internet. That is possible because you typically connect your client machine, so your laptop or your desktop computer, via what's called a local area network. All right, so I'll be a network that is restricted to a particular geographic location, for instance, or to a particular organization. Yeah. Anyway, again, all we are saying here is that we're taking advantage of this communications infrastructure because what we're doing is we have our client machine send through data, which is typically a request, and the server, in the case of an MIS, will send back a response, right? This request response cycle at play here. What we see here is that we also have other additional hardware components that will facilitate this transmission of data, right? So network devices such as routers, radios, and hubs. Yeah, and all you're doing really is transmitting these electric signals via this computer network. Again, just further reiterating the fact that when you're dealing with a computer network and you're transmitting data, all you're doing is, or all that's happening is that the different network nodes within that computer network would be exchanging data, right? And again, these network nodes will encompass a broad spectrum of hardware. It's the classic computer systems, both microcomputers and server computers. You have, printers, scanners, IP phones, and network servers. Again, just like a high-level overview of what would be typically happening in a typical organization, right? Yeah, so this could be viewed as, an existing computer network that is used in such a way that these different network nodes are exchanging data or sharing resources via the existing infrastructure. Some network nodes will be able to share or access resources wirelessly, whilst others will require a wired connection. Yeah. Again, I think we already made mention of the fact that the so-called client-server architecture, where we had this internet cloud, essentially makes reference to a computer network. So this internet here is a computer network. And in fact, this internet could just as well be a local area network or a metropolitan area network, or yet another different type of wide area network, like a virtual private network, for instance. In summary, in terms of the resources, a reminder here that the reason why we have a computer network is we're interested in sharing resources. And for the most part, the resources that we'll be accessing would be the resources that are hosted on server computer systems. But you must remember that there are other resources, other unique resources like specialized hardware, right? That will be accessing not necessarily from server computer systems. So fundamentally, we see that computer networks will facilitate communication. They'll facilitate the sharing of resources, and they'll make it possible for us to gain access to data, right? And really, in essence, this ecosystem, right, or this interconnection of network nodes or network elements is the thing that facilitates the effective collection of summarized data, transformation of that summarized data, and eventual extraction of information from the transformed data when you are accessing a management information system. I don't know if there are any thoughts so far before we just briefly talk about, I'm not really sure if this discussion is going to be relevant, but hopefully to make us better understand this whole notion of computer networks, so-called network topologies. Are there any thoughts or questions about this? Perhaps specific questions that you might have related to your experience using these different types of networks. Networks have evolved now, right? There are, well, not there are actually. Fibercom has actually been aggressively advertising now. They're providing last mile connectivity. This, on 2 occasions, I've actually bumped into people laying down fiber. I don't know if you guys live in a part of the country where fiber is being laid closer to where you live, but at some point I met them right outside where I live, right? So our adjacent neighbor had actually, I think they paid money for Fibercom to actually lay fiber, right? And then this other time when I was cycling somewhere near, is it Airport Road or something, I found them, I don't know if they were fixing a damaged fiber connection with they were laying down completely new connection here, but I came across them nonetheless, right? If you haven't heard of Fibercom, you may want to look them up. It's actually a cost-effective way of accessing the internet these days, right? Not only that, it's much faster. So if you obsess about things like streaming, Netflix, for instance, this is the way to go here, right? Also, I would be interested in knowing if at your respective workplaces, perhaps, if you at your respective workplaces, you actually take advantage of fiber, right? Or fiber is integrated within your existing computer networks. Any thoughts about that? No thoughts. Okay. It's a bit weird, but that's fine. All right. So the idea behind network topologies really is it turns out that depending on what sort of services you want shared within, let's say, an organization, and also depending on the sheer size of the organization, you may decide to seriously evaluate the different alternative approaches available at your disposal insofar as interconnecting the different network elements is concerned, right? So this logical layout, it's like if you look at UNZA, for instance, would have to make a decision on how the computers used within the School of Education building are going to be interconnected with each other, but also how those computers are going to be interconnected with computers that are used within the School of Natural Sciences building, computers used at the School of Engineering. This logical design is what's referred to as a computer network topology, right? It's just a different alternative ways of interconnecting network nodes, ideally, right? And it turns out that this logical design needs to be properly planned for and structured. One of the reasons you want to do that is to ensure effective communication. But also in the event of a failure, you don't want to seriously inconvenience people that will be exchanging information within the network. So some common types of network topologies here would be things like the bus topology, star topology, and the tree topology, right? We're just going to go through these things in sequence so that we gain an appreciation of what they're all about. So when it comes to a bus topology, by the way, the visual representation just showcases how the different network elements would be interconnected with each other within the bus topology, right? So we see that the network nodes, so your computers and these other specialized hardware devices like your printers or your file servers, for instance, would be connected to a logically shaped line, right? Similar to what you're seeing in the diagram. And it turns out that the information that is being sent to and from the different client machines will essentially travel to each and every node on its way to a destination. So if the information is originating from this node here at the beginning, the left side, and is destined to the last node to the right, when you send a data packet, it's going to hit each and every one of these nodes. Some key characteristics associated with this type of topology is that it's generally relatively easy to interconnect these network nodes within your network. But also it has the obvious advantage of requiring significantly less communication medium. So if you think about the communication medium that is used relative to, let's say, the wired connections, you would need far less cables to interconnect the different network nodes, right? Probably the simplest you can ever go here. It turns out that this is generally suitable for large organizations. So if you're an SME that has maybe 3 or 4 people working in that organization, you're better off, designing this network topology associated with a bus topology, right? So all of the people would connect their devices to this sort of network, ideally. So the fact that this is generally appropriate for relatively smaller networks or small organizations is a disadvantage, right? Because if you're looking at interconnecting network elements or network nodes for a relatively large organization, this sort of setup becomes unsustainable, right? Or less desirable. Anyway, it's also difficult to troubleshoot problems, right? So in the event that you are unable to send a packet from this computer to, let's say, the last computer here, it's incredibly difficult for you to identify where exactly the problem is originating from. There's also this disadvantage of you having a single point of failure, right? So if, let's say, this line here that is being used to interconnect all these different computers is damaged somehow, it would be difficult or it would be impossible for this network element or node to be able to communicate with the other network nodes. Yeah? So you have a single point of failure essentially. You also have the option where you have a so-called star topology. And the idea behind the star topology here is you typically interconnect these different network elements to some central hub. Right? A hub is essentially it's a network device. I don't know. You may have seen these at your respective workplaces. I don't know if what we have in somewhere close to the bathroom here is a hub or a switch. I'd have to check here to confirm. But I'm sure you've seen these things at your workplaces, right? Depending on how large your organization is. And typically there'll be like an Ethernet cable, something similar to this, that is used to connect the computer that you use to this thing here. So the idea is data originating from one network node has to pass through this hub. And the hub is used to transmit that data to the destination node, ideally. Is there anybody who works for an organization where you have this sort of device in use, especially those of you that work for relatively small organizations? I think we have somebody who works for a not-for-profit organization. Usually those are the people that would typically have this sort of setup. Any thoughts about this? Okay. I wonder if people can already think about obvious, advantages of this sort of setup. I don't know if you can think of any thoughts about obvious advantages for the star topology.
Okay, so I think it is very easy to spot where the failure is. Suppose one computer is not receiving or is not responding. So it is very easy to spot. It's okay. The cable connecting this computer obviously has got a damage somewhere.
Right. Yeah, that's true. I mean, that's an obvious advantage. And I think a nice way to think about some of these advantages and disadvantages is relative to like these topologies that we've already discussed, right? If you remember, we said that one of the drawbacks of this bus topology is there's a single point of failure. But because, to some extent, there is a single point of failure here as well, which is the hub here, right? This device here that is used to interconnect all these different network nodes here. But the beauty is if there's a problem with the hub, you'll easily be able to figure out that the problem is with the hub, and all you'd need to do is just swap out this hub or this network node with a completely new one or something. Yeah, so that's a classic, I guess, advantage. Thank you very much for that. But if you think about it, it's also relatively easy for you to scale, right? So for you to add additional network nodes, all you need to do is make sure that you have a hub that is capable of, or that has a provision for you to interconnect the total number of network elements or network nodes associated with your organization. So you have a choice to buy something like this, which has like 4 ports here, or a significantly larger hub, I guess, that has more ports, right? And all you have to do is just invest additional money in the communication medium, the cables, the actual cables, the Ethernet cables. I guess the things that you'd be considering as the disadvantages here would be, if you notice, if you just look at this diagram, there's a very strong dependency on this this device here, right? The hub itself, right? If it fails, then well, these computers will not be able to communicate with each other. Because this is a single point of failure, the other disadvantage perhaps could be that it becomes costly for you to maintain this as well. Anyways, also, if you think about it, this may not necessarily be obvious here, but because of this dependency on this single point of failure, in instances where you're scaling up and adding additional nodes, you notice that the performance, right, of your network tends to degrade as you add more and more nodes. But anyways, so we've already made mention of some of these advantages listed here. But you also have the classic tree topology, right? And the beauty with the tree topology, if you look at the diagram here, is it essentially will incorporate the best of both the star topology and the bus topology. Just look at this diagram here. So the idea behind this is that you typically be setting up a cluster of so-called star topologies. A classic example of an environment or an organization that you'd want to set up this sort of topology is the UNZA, right? So these different clusters, the star topologies here could be schools. So a school of education, right, would have a cluster of nodes, the school of engineering, the school of mines, and then all of these here would be hooked up to this larger organizational network, making it possible for resources that are common between these different schools to be accessed. Like if you have a storage server, for instance, or application software such as SIS, such as the learning management system. Whether you're in the School of Education, the School of Humanities and Social Sciences, the School of Natural Sciences, you access the same learning management system. You access one SIS, yeah? Anyway, so in essence, it's just a hybrid topology, really. And so the obvious advantages here is that it takes into account the best of both worlds here. Easily scales, right? You can continuously add more and more network nodes without really compromising the performance of the network. It turns out really that sometimes, though, the disadvantage again is you can't get away from this. If the backbone network, so this network through which all these different clusters are connecting to the main network, goes down, then obviously certain services may not be accessible. There was a time when I think we were not able to meet because I was attending an event somewhere. We were told that a switch, right, one of a new switch that was purchased had gone down, and all the other services were inaccessible, right? And so somebody like me who was accessing the user network via some external network, let's say MTN, for instance, would not be able to access that service because the backbone network was down ideally. I'm not sure if people have any thoughts about network topologies. The closest you ever get to discussing network topologies, I guess, is let's say you're part of the team that is overseeing the design and implementation of the social protection management information system. One of the things that would have to be discussed is where exactly this MIS platform is going to be hosted, right? And how the different end users within your organization will be accessing the management information system. And then maybe your network administrators or system administrators will offer suggestions to say, for people in the organization to be able to access this application, would need to make alterations to the network topology or something. Maybe you'll have something to contribute because we've had this discussion. It turns out that if you really soak in this discussion of network topologies, you begin to realize that there are some important factors that will tend to influence which topology you're going to settle for. There's the cost implications, right? So economies of scale here. Some of these topologies are more costly than others, right? So you have to take into account how much money you'd have to invest in setting up this sort of topology. Do you have the financing to purchase like expensive network devices like hubs and switches, for instance? Do you have enough money to invest in, and I know these are cheap, but to invest in the communication medium required when you set up a tree topology, for instance, right? And all those things. But there's also things like specific network infrastructure requirement, right? Such as the relative effort required to actually lay down, this ties into the cost really, but to lay down the communications infrastructure. Do you have the expertise, or are you going to have to hire an external contractor to set up this network for you? For some networks, like a simple bus topology, you actually wouldn't really need an expensive consultant to help you plan for this, right? It's something that can really be done in less than a day, actually, within a day. But you have to take into account factors like scale, right? In a year's time, in 2 years' time, do we expect that we'll have additional network elements or network nodes on our network? Do we expect that we'll we'll have more people join the organization, which will warrant the scaling up of the computer network? There are other factors that are not listed here, like whether you're dealing with a critical resource, right? It could be the case that the management information system that you're setting up in your organization is something that needs to be accessible 24/7, in which case you have to seriously consider the type of topology that you need to set up. I don't know if there are any thoughts here about this before we transition to our discussion of the specific types of computer networks. No thoughts. That's okay. All right. So it turns out, right, if you remember at the very beginning, we were showcasing some, like in double back here, we were showcasing some typical examples of computer networks, right? It turns out that these different networks can be categorized into subcategories or groups, really, right? And we're just going to briefly discuss some of these things. I imagine you've actually had experience with some of these categories here. So first up, the simplest possible network you can set up is your so-called personal area network. So this would be a sort of network that you'd use to interconnect several personal devices that you'd have. Typically you'd set up this sort of network when your devices are in close proximity with each other. And the simplest possible technique, which I think most of us have used, is maybe you say you have a laptop at work, but you need to connect to the internet. What you do is you create a hotspot on your smartphone, and then you have your computer join that network, right? So what you've created is a personal area network. Although it's slightly complex then, because one of the reasons why you'd be creating that personal area network is so that you gain access to the internet, in which case you're actually hooking up to a wide area network. But in essence, what we're saying is we're defining a personal area network as really an interconnection of personal devices that are in close proximity with each other. I don't know if you people have other use cases, personal use cases that have necessitated you creating a personal area network. What I do when I'm at home is I'll normally interconnect a number of my devices, right? So my laptop at home or my computer at home with the one I use at work, and my smartphone would have to be interconnected somehow so that I can easily move files, right? I'm copying files across from one laptop to the other, for instance, right? So personal area network. You also have what's called a local area network. If you look at the characteristic local area network here, we're looking at a computer network where the host would be co-located within a small geographic area. Now, this is obviously a bit subjective here, right? Because how do you define this, a small geographic area? A nice way of thinking about a small geographic area is when you look at specific use cases, like a company or an organization, such as UNZA or ZRA, right? Or Ministry of Community Development and Social Welfare, for instance. When you have an organization where individuals are co-located within the same building, for instance, and they are connected to some network, that network would be classified as a local area network. All right. So again, this is why we have these examples like networks associated with these higher education institutions, or a network associated with some primary school or high school or something, or really a small company, right? And the example of the SME I gave here, that would be a classic example of a local area network. But it turns out that things may become a bit murky here. If you look at UNZA, UNZA has what? UNZA has Great East Road Campus. UNZA has these regional campuses, right? UNZA has I think we have a Kitwe campus. UNZA has Liempe Farm. I don't know if Liempe Farm is hooked up to the larger UNZA network here. But also, UNZA has what we used to call medical school. We'll call this medical campus or something. Or we'll just call this, what the formal way, it's Ridgeway campus. What we are saying is that, by definition, if you look at the definition of local area network, what we're saying is that the Great East Road campus is an individual local area network. So is the Ridgeway campus. So is the Kitwe campus. So is the network at Liempe Farm is a network. I imagine there is a computer network. So are these different regional campuses like Chipata, right? I don't know if Kasama has a regional campus or something. These are all local area networks. We'll be back to that example just now. So there's also what's called a metropolitan area network. In essence, by definition, a man or metropolitan area network is really a computer network where the hosts are located in some metropolitan area. So it could be like a town or a city or something, or a district, right? So we could get away with the fact that Great East Road Campus and Ridgeway Campus will form what's called a metropolitan area network. In the example of UNZA here. All right. So there are examples here, right? We're saying that we're making use of the university campus here, like UNZA, right? Because UNZA in Lusaka has a number of these locations, like the Great East Road Campus, Ridgeway. There's IDE. There's is it Ineso or something, right? Somewhere in just somewhere close to Munari Road here, just adjacent Munari Road. All of these will constitute what we can arguably call a metropolitan area network. So in essence, you notice that these definitions, whilst there's a thin line between some of these definitions, but we are tying these to the boundaries, right? The geographic location. For a personal area network, we're saying these are devices that are in close proximity to each other. And typically, this type of network would be associated with an individual, whereas a local area network would be an interconnection of computers in a small geographic area, typically the same building, if you will, right? Or company premises, organizational premises. And then a metropolitan area network would be an interconnection of network elements or nodes in the same town or something like that. Hopefully all of these things are making sense here. And then you have what's called a wide area network. By definition, this would be a computer network where the network nodes or the hosts are located over a significantly larger geographic area. Now, this is where I was saying this is contextual, right? Because one would argue that if you look at Great East Road and Ridgeway campus, one would argue that the two would form arguably a wide area network, right? Although we can also argue that the two can form like a metropolitan area network. So larger geographic area. In some instances, this involves interconnecting multiple lands. So we see that the network that comprises Great East Road campus, Ridgeway, Kitwe campus, Liempe Farm, and all of these regional campuses in various towns within Zambia will form a wide area network associated with the University of Zambia. If you think about this discussion relative to what typically happens when you're accessing the internet in Zambia, what we're saying is that the MTN network and the Zamtel network, right, and the Airtel network, because in as much as I'm using Airtel on my phone and I'm taking advantage of Xamarin on my computer, all of these two network elements here can communicate with each other because they're connected to the same network. This network is a wide area network. It's an interconnection of different local area networks and, in fact, metropolitan area networks. And in fact, it could be an interconnection of wide area networks. As luck would have it, one of the so-called largest wide area networks is what we call the internet. We see that the internet is nothing more than an interconnection of sub-wide area networks. So the UNZA wide area network would be a part of the internet, or at least the nodes that are connected to the internet. If you look at Zambia, the network associated with MTN, Zamnet, and Zamren, Fibercom would all constitute individual wide area networks, one would argue, which when hooked up to the internet would be a part of that larger wide area network. Anyway, it turns out though that there are instances when you would actually need to gain access to resources in such a way that these network nodes would be interconnected with each other, but then they may not necessarily be connected to the internet, if you will. What you do in such instances is you form what's called an intranet. In essence, it's something that's akin to the internet, but it's just restricted to a specific organization. And in some instances, there's a deliberate policy put in place for certain types of crucial resources to be accessible only within the intranet. You probably work for certain organizations where they've told you explicitly to say, for you to access this type of service, a piece of software, you have to be on the network. It's usually a security mechanism, right, to try and reduce the likelihood of external attacks on your organization. I wish I could think of specific examples that are accessible only within the UNZA network, like FTP server. If I wanted to access the UNZA FTP server, I wouldn't be able to access it. I know I can access it by FTP. I don't know if it's UNZA.zm or something. Maybe not, but if I say FTP here, ftp.unza.zm, I don't know if I'll be able to access this because I'm on the UNZA network. I don't know. I can't, but that's fine. Last time I checked this, I was only able to access the FTP when I was on the internet, right? So the UNZA, or when I was on the UNZA network, in essence, the FTP server forms what you would call your intranet, right? Some instances, your organization may set up what's called an extranet. In essence, you would be interested in having other individuals from separate organizations to access important resources on your network as an organization. I guess the example I can think of here are so-called mobile network operators in Zambia here, right? There's also what are called virtual private networks, or so-called VPNs. I don't know if you've come across the word VPN. The idea behind this is you take advantage of some public communications infrastructure like the internet to create a secure connection within your organization. So for instance, if you're an organization like UNZA that perhaps might be handling sensitive information that needs to be transmitted between your regional offices and Great East Road campus, and you don't want users to use the public internet because it's not secure, what you can do is you can approach an organization like MTN to pay additional money to create this virtual private network specific to you as an organization, as UNZA. And so your users will be able to communicate and to send data in between the different network nodes here using this virtual private network. At some point, I think when I was working in the telecom sector, I don't know if this service is still being offered. It was a cash cow for Airtel, was it Zen at the time? Because there are a number of organizations that were willing to pay extra. At the time, we didn't have the luxury of having pre-existing, pre-existing networking infrastructure like this, right? So we're solely dependent on these MNOs here. And for you to securely transmit data in between the different network nodes on your organization, you'd set up a VPN or something. I'm not sure if people work for organizations where VPNs are used. Anyone, any takers there? Or maybe you just don't know. Maybe you use a VPN and you don't know. There was a time when I was facilitating training for our colleagues from ZRA, Zambia Revenue Authority. And one of the things we needed to do is we needed to access a server on the ZRA network. We couldn't via the UNZA network, right? Because it's blocked. The only way we'd be able to do that is if they could tunnel into that organization via VPN or something. And there's typically special software that you use for you to be able to do that. Right? So there you go. Anyway, so it turns out that all of these different, networks that we've discussed, VPNs and extranets and intranets, things like LANs and MANs and WANs and PANs, for instance, you'll notice that there are specific network characteristics, right? Or specific factors associated with these different networks that we've discussed. Like, for instance, the relative size of the organization will determine the type of network associated with your organization. In some instances, the security requirements of the organization. I just gave an example of ZRA. ZRA would want to set up a virtual private network because they arguably handle sensitive information or sensitive data. In some instances, you could have policies and procedures in place within the organization that requires that you have certain special types of networks. I imagine some of these processes and procedures could be associated with legislative documents that might exist, right? In some instances, it could be details on how your management information systems or information systems are supposed to be accessed within the organization. And one would argue that this is tied to policies and procedures, really. So there could be a requirement to say, for you to access this social protection management information system, you must be on the organization's network. If you're not, you will not be able to access this piece of software, intranet or extranet or something. I don't know if there are any thoughts here about this. I'm trying to see here if we can. I guess we can finish this off today. Are there any thoughts about the different types of computer networks? And I hope people are able to piece the different pieces together here. In as much as we've highlighted on numerous occasions now the role that the communications infrastructure plays insofar as the management information system is concerned, I hope we've been able to relate all these other different things that we've discussed, like the different types of computer hardware that you find on a computer network, right? network devices, hubs, switches, and routers, and all these things. The reason why you need this communications infrastructure, the fact that your typical management information system will be web-based, right? If it's web-based, you're accessing it via a network. If it's web-based, you're using a browser to access this service. When you're using a browser to access this service, the service is accessible over a network. If a service is accessible over a network, there has to be some existing communications infrastructure that you're taking advantage of. All right? Your bundles may not be sufficient here. Anyways, just highlighting something that perhaps we've already mentioned. We mentioned that these different network elements would be interconnected with each other somehow, right? There are two primary ways of interconnecting network nodes. You can connect them wirelessly using wireless technologies, Bluetooth, Wi-Fi, they call it sometimes, or you can take advantage of wired connections, copper wires, Ethernet cables, or the more popular fiber these days. And all of these decisions are based on the type of network or the sheer size of the organization you're referring to. Fiber. MTN, when you're using MTN to access the internet, you don't connect to the MTN network via fiber, right? You're connecting to these towers, is it? It's a completely different communication medium that is being used there. Takes advantage of Wi-Fi technology. Anyways, yeah. I think a few pointers on what we introduced as perhaps one of the largest wide area networks, the internet. It becomes important for us to discuss the internet because fundamentally most of these MIS platforms would be accessible via the internet. This is in fact what I would like to think here. This is in fact what those of you that work for the Ministry of Community Development would do, right? When you're accessing ZSpace. I don't know if you have any thoughts about that, but can you access ZSpace via when you're connected to MTN, when you're using your MTN bundles or your Airtel bundles? Any thoughts about that? Does anybody know? Or you can only access it when you're on a specialized network that is at the office or something? Nobody knows. These are maybe things to try out if you don't know, or to experiment with, if you will. Anyway, so what we're saying is we see that these management information systems or management information system platforms or applications, a special type of application software we introduce as web-enabled or web-based applications. So they are made available via public computer network called the internet. And we've just made mention of the fact that the internet is actually a classic example of a wide area network. All right. These are just a few notes about the internet here. There are different views about the internet. You know, it's perceived as being a community of people who use and develop the networks, the different networks associated with the internet. Another way of looking at the internet is it's just a collection of different resources, right? That can be shared amongst different networks. You use the internet because you want to access your Facebook account so that you see what's on the Zambian watchdog page or something. You use the internet so that you keep track of what your favorite TikToker has posted. You use WhatsApp so you can check for the most recent tweets, right? Tweets associated with some influencer that you follow religiously or something. You are accessing different collections of resources via this public infrastructure called the internet. So in essence, we see that the resources that we're mostly accessing via the internet really are applications and data. It's rarely the case that we'll be interested in hardware, right? If you remember our definition of why networks are important, we mentioned that networks are there because they facilitate the sharing of resources. These resources are not just applications, but they could be hardware, it's data as well. When you're dealing with the internet, it's rarely the case that you'd be accessing hardware, unless if you're doing something sophisticated that is to do with research, right, where you want to access a more powerful, safer computer system over the internet, right? But anyway, so be viewed as a collection of resources. But also, what's important is to highlight that there's a specific standard that is used to interconnect these different nodes on the internet. It's called the so-called TCP/IP protocol. Right? And in essence, really, these internet applications that we access via the internet will typically use a communications protocol that is specific to how they operate. So depending on the type of service that you're interested in on the internet, you use a specific protocol. Classic services that most of us use on a day-to-day basis would be a service that facilitates the receiving of email, a service that will make it possible for you to access a web application. All right? A service that will facilitate you remotely gaining access to a server computer system, maybe located in a different country. Right? So a number of services. This is an interesting point because it turns out that a lot of people misrepresent what the internet is. When you talk about the internet, the only service people will think about is the service that allows you to access websites, web applications, right? But you must remember that in some instances, you would actually download and install an email client that will make it possible for you to maybe send and receive emails, right? So your IT department will tell you that, oh, we've set up an email exchange server, a Microsoft Exchange server or something to help with receiving and sending of emails. Or we've set up a file server that will make it possible for you to access important files on the organization or within the organization using FTP protocol. Those are all different types of services that are available on the internet. Again, just some commonly used applications. File transfer will typically use a protocol called FTP. Electronic email will use a protocol called SMTP or IMAP. So SMTP for receiving emails, IMAP and POP for receiving. For receiving emails. SMTP for sending emails, IMAP and POP for receiving emails. You access the World Wide Web, these web applications and websites associated with a service linked to the World Wide Web. So you access these websites and web applications using the HTTP protocol. All right. So different types of services here. And I guess we can leave it at that. I thought it would be important for us to just briefly talk about those things here. The next time we are meeting, we are going to have a discussion of data sources with a specific focus on databases, in part because a typical management information system will store data that is the summarized data that is collected in a database. I want to pause here and ask if people have any specific questions about this. Okay. All right. Ladies and gentlemen, thank you very much. I will see you when you see me, which is, I think, Saturday it is. We'll start our discussion of data sources. Thank you very much.